In this video, we're going to practice converting between concentration and pH, as well as finding the pH from more regular measurement values such as mass. So try these 3 problems. Go ahead and pause the video, and then come on back and we'll work through them. All right, if you're back, let's look at problem A. I want to find the pH if I have 3.5 times 10 to the minus 5 molar H+. Well, our pH is equal to the negative log of our H+ concentration, so the negative log of 3.5 times 10 to the minus 5. This comes out at 4.456 for its pH value. If we think about that for a second, well, my concentration is 10 to the minus 5, which is more than 10 to the minus 7. So it is definitely more acidic, and our pH value is less than 7, which is more acidic. So this seems to be working correctly. Problem B, let's find the concentration from the pH. So in this case, we have a solution whose pH is 9.875. What is the molarity of that H+ ion in solution? Remember that our 10 to the negative pH will give us the molarity of the H+. So this is our equation where we can convert pH into concentration. So in our case, that is 10 to the negative 9.875, which is 1.33 times 10 to the minus 10. If we think about that concentration, 10 to the minus 10 is way less than 10 to the minus 7. So we have way less H+ than neutral water. And our pH is 9.8. It's larger than 7. And the larger your pH, the more basic. So we seem to have a less H+ solution. So we should have a more basic solution. And that's what our pH tells us. Finally, problem C. Well, a lot of times we weigh stuff. And so we need to determine the concentration so we can find pH. In this case, I have 1.3 times 10 to the minus 3 grams of HCl. If I want to find that pH, I need the concentration of H+. To do that, I'm going to have to get moles and liters. So I need to do a few conversions here. I need to get out of grams of HCl and into mole of HCl. Approximately 36.46 grams of HCl in every 1 mole, which comes out to 3.566 times 10 to the minus 5 mole of HCl. That is in 350 milliliters, or 0.35 liters. So 3.566 times 10 to the minus 5 moles of HCl over 0.35 liters of solution gives us 1.0187 times 10 to the minus 4 molar HCl. Well, since every HCl will break apart into an H+ and a Cl- because it's a strong acid, that translates into 1.0187 times 10 to the minus 4 molar H+. It's a monoprotic acid, so it gives away only one H+ for each HCl. Now we have our concentration. My pH is going to equal the negative log of 1.0187 times 10 to the minus 4. The pH for this solution should be 3.992, and realistically, we had 2 sig figs, and so at the end we should get 2 sig figs. So this should round to approximately 3.99 for its pH.